In this video, I'm going to help you to set up a system of linear equations in order to solve each of the following problems. So we always need to come up with two equations made up of two variables. This problem is something that you would have seen before, where you have a cost associated with two different, a cost per person and a fixed cost associated with two different banquet halls in this case. So first we need to figure out what our two variables are going to be. C can represent the cost, or the total cost. And we can let G represent the number of guests. Then we'll have equation 1 for Limestone Hall to be $5,000 plus $75 per guest. So the cost equals $5,000 plus 75 multiplied by the number of guests. And you can switch this around to be in the y equals mx plus b format, but it doesn't have to be, because we know that there's more than one possible way of solving this equation. For equation 2, we're going to have $7,500 plus $50 per guest. So the cost will equal $7,500 plus $50 per guest. Okay, when you're solving this system of equations, your goal is to find the number of guests for which the two hall costs would be the same. I'm not going to be solving all of these. That's something that you can do on your own. We're just trying to set it up so that anytime you have a problem where it's option A versus option B, you understand what the general setup will be. In the second problem, it's the style problem where you have two clues, and the two clues will relate two unknown values. So once again, we need to figure out what variables we want to use to represent the two unknown values. In the question, you can see that you're trying to find out how many cars and how many trucks. So we will let C represent the number of cars, and we can use T, and we'll just try to make it a fancy T, not to get confused with the addition sign, the number of trucks. Reading through the problem, it says that Christian has a total of 8 toy cars and trucks to play with. So if I add C plus P, that should equal 8, and that can be our first equation. There's another sentence in this problem that relates cars and trucks, and it says that he hopes to double the number of cars he has now. So double the cars, and if he does, he will have a total of 11 cars and trucks. So if he doubles the cars plus the trucks that he has, it will equal the number 11. Okay, and now you've created a system of equations that can be solved using substitution, elimination, or graphing to find the number of cars and trucks that he has now. Another style question is a question that has two totals, and one total is a statement where you have an absolute total, so a total statement, and the other one is a statement with values, so how much something is worth, whether it's money or some other type of value associated with it. And in this case, we're talking about movie tickets, and we're asked to find out how many of each type of ticket. And if you read through the question, you'll see that there's two types. You can have tickets for adults, so we'll use the letter A to represent the number of adult tickets sold. So keep in mind it's not the number of, it's not the price of the adult tickets, we have that information. It's the number of adult tickets sold. And C will be the number of child tickets sold. Child tickets sold. Okay. It says that the total amount of tickets, so the total number of tickets is 400. That's not involving price at all. It just says the number of tickets sold So A plus C will be a total of 400 tickets. So that's the total statement. There's another statement involving value, and the total value is $4,650. Okay, and that's with reference to the cost of the tickets. So if we have a certain number of tickets sold that are adult, and they are $13 each, then 13A will represent the money associated with the adult tickets, plus 8C, the value of children's tickets. So $8 multiplied by the number of tickets sold will equal the amount, the total sales related to children's tickets. So we have adult tickets plus children's tickets sold in terms of value have a total value of $4,650. So here we have a system of equations that once again can be solved by substitution or elimination or graphing, and you can try that on your own. As I mentioned, there are other types of value type problems, and in this case it has to do with the strength of an acidic acid. It's more of a science problem. And there are two types of acids in this question. There's an acid that has a strength of 5% and another acid that has a strength of 10%. So because we're going to be mixing the acids together, our variables will have the 5% acid be the letter F and the 10% be the letter T. So the variable will represent the amount of 5% acid, acidic acid, and it's going to be measured in milliliters. And T will be the amount of 10% acid, acidic acid, also measured in milliliters. Okay, so what we know is that if you just take the amount of acid, so F plus T, that's going to be the total. The amount of liquid in our new container, because we're going to create a new mixture, is 250 milliliters. So it could be 100 and plus 150. It could be equal amounts at 175 and 175. Sorry, 125 and 125. We don't know. So that's our first statement, that the amount of 5% plus the amount of 10% equals 250. As far as the value is concerned, you have to think about the strength of the acid. So 5% acid, remember when you write 5% in a math question, you're going to write it as a decimal. 5% can be represented by 0.05. It'll be 5% of the amount of liquid, that's 5% acetic acid, plus 10%, and the 0 at the end might not be necessary, but we can include it just to make it clear, multiplied by the amount of 10% acidic acid. So the strength is 5% of this plus 10% of that equals a new acid that's 0.08, 8%, of the total, which is F plus T, and we know that that's 250 milliliters. So you can't just write a percent, you have to say the percent of something. So percent of the 5% acid plus a percent related to the 10% acid, so the strength of each, equals 8% of our total. Okay, so we have equation 1, and for equation 2, I'm just going to actually work that out. So this works out to 20. So 0.05 F plus 0.1 T is equal to 20. So that's our second equation. And now we, again, have a system of equations. Okay, next we have more of a business problem. We have expenses and revenue. Expenses would be the money that you spend, and revenue would be the money that you earn, but both of these values in terms of amounts would be money. So we're going to need a variable, we'll use M to represent money. The This is a dollar amount of money. And in this case, the product that's being sold and made are pies. So P can represent the number of pies. So not the cost of a pie, but the number of pies. And then we can read through the problem. It says that when you're making pies, the ingredients that are used cost $3.75 per pie. And also, to make pies, you need to rent an oven that is $54. So to the expenses, so we're going to do this equation first. The expenses will be our equation 1. So the expenses are that the money that we need to spend will be $3.75 times the number of pies plus $54. So once again, you have the fixed cost at the end and a variable cost. And the second equation will represent the revenue, or the money earned, and the money earned is $6 multiplied by the number of pies. So if you sell one pie, it's $6. If you sell two pies, it is $12, 3 pies, $18, etc. So now we have this system of equations where one of them represents the amount of money spent, those are expenses, and the other one represents the revenue, or the money earned. In this case, we're going to solve and try to find out when it breaks even. So if you break even, then money from equation 1 will equal money from equation 2. So that's what we're trying to find out. When does M equal M? Okay, and last but not least, this is another science or physics problem. And in this case, it's a distance, speed, and time problem. So we're going to use this hint here that distance is equal to speed times time to set up our two equations. In this case, the distance that you're traveling is given. It's at 12 kilometers down the river. The time is given. We have two different times. And the reason there's two different times is because in one direction, the canoeist is traveling down the river. And that part is going to be easier than the return trip, because in the return trip, you're going against the current. So the speeds, or the variables that we're going to need to calculate, is we need a paddling speed, so paddling rate. The canoeist will be paddling at a certain speed. Okay. But we also need to know, so this is a speed, we also need to know the speed of the current, because the speed of the current will either help the canoe to go faster or will slow it down, having the canoeist take longer to travel the same distance. So for equation 1, we'll do the canoeist is traveling down the river. So this will be our equation 1. The distance is 12, and 12 equals a speed of the paddling rate plus the current, because the current's going to help you, multiplied by time. And the time in this case is 2. Okay, and then for the second equation, we're going to go against the current. So it's still a distance of 12. In this case, though, the speed is P subtract C, because you're not going to be able to go as fast. You're going to be paddling, or the canoeist is paddling at speed P minus or hindered by a certain current, a speed of the current. And we're going to multiply that by 3 this time, because that's the time. And just because we're not used to seeing it in this format, we're going to distribute this number 2, and we're going to distribute the 3 before I write my final equations. So equation 1 will be 12 equals 2p plus 2c, and equation 2 will be 12 equals 3p minus 3c, and this system of equations can be solved using, once again, either elimination or substitution. Okay, and lastly, for homework, you're going to read through the problems that are listed on these pages, so there's a number of problems. I want you to try and compare each of these new problems to one of the ones we've done. So if it looks like it is a comparing problem between two options, just like the banquet halls, then you can say that it looks like equation number 1. Or sorry, like example like number 1. Okay. If it seems to be a total value problem instead, then you can change and say, oh, well, that's more like question number 3, or example number 3 or 4. Okay? At the end, you're going to choose any 5 of the problems to actually solve for homework tonight.